Alright, I'm back. So a question you might ask about this place is, why is it here? Well, you can kind of get a feel if you look around. So we're at the base of a hillside, and at the base of that hillside is a seepage. So there is a hydrology, in other words, a study of water and water structure. There is a hydrology here that allows the water to seep out at the base of the hillside. And if I kind of zone in here, you can see that that water is slowly coming down here, and it's making its way along the base of the hillside in a black ash seepage swamp. I'm just going to walk a little bit here, and I'm going to film just a titch so that you can kind of get a sense for the area. And I'm going to walk over to where I have a black ash. So I'm walking there now, and walking through here. I'm going to show you the black ash. So here we go, black ash. Now I don't know if you would just immediately recognize it as a black ash. It's not like its bark is that descript. So I'm going to cheat a little bit and use a photo to really help out. So here we go. Here's my black ash. So if you look at this photo, this is a little more mature tree, and it does have a particular texture to that bark. And if you look at the black ash leaf, that is actually one leaflet. I'm sorry, it's one leaf made out of a number of leaflets. So here it's showing 9 leaflets. That's pretty typical. You can have upwards of 11 or perhaps 13 leaflets making up one leaf. The other thing about black ash versus, let's say, green ash that you'd probably find at a floodplain forest is that black ash has no stalks that come away to the leaflet. No little stalks, so you say it's sessile, a term that's often used actually for animals that don't move, sessile. Here it's used to refer to the fact that there are no small stalks that lead away from the main branch to the leaflet. So that's black ash, which again is kind of the namesake to this area. So far we've got the idea that this is a seepage with that distinct hydrology of the area, and we've got the black ash namesake for this area, so that's awesome. Okay, now I'm just going to walk around a little bit and show you some of the unique plants that you might find here. Sadly, my photos went in the seepage. I'm just picking those up, and I'll be with you in a second. Okay, I just saw a plant that is of interest to this area. It's kind of last year's old stem, but it'll help. So you can see I've got this plant right here that's a tall guy, and you can get a feel with my finger as to the width of the stem. This is called Angelica. I'm going to help a little bit with a photo. So here we go, this is Angelica. You can't really see it at this point anymore, maybe a little bit. Here we go. There, this is the seed head, and that's an old seed head from last year, Angelica. So it's got this wonderful kind of big top inflorescence on top of a stem that's pretty, got some pretty good girth to it, and that is Angelica. Now I see another one I'm going to show you in a sec here, and that's sensitive fern. Well, you can't actually see the fern right now, but I'll show you the spore frond of it. So right here, this guy that's right here. That's the spore frond from last year. So ferns don't germinate from seeds, they germinate from spores. They are a vascular plant. They have xylem and phloem, but they don't really grow that tall, and they grow from spores. So they're a little bit different than a typical seed-bearing plant. I'll show you a picture of the actual plant itself. Here we go. This is a sensitive fern, or its genus name is Onocloa. If you look at it, you know, I don't think you can mistake it for another fern. It's got such a unique leaf that composes it. So that's sensitive fern, and right here again, that's Angelica. Now I spied another one over here somewhere. I'm going to find it here for you. Let's see if I can find it. There we go. So there are sort of hummocks of sedges, like this one right here. And it's a little hard to tell right now, but I'm thinking that this is called lake sedge. So a typical way, it's not fault proof, but a typical way that you know a sedge is that the base of it is very triangular. Sometimes people use the mnemonic sedges have edges, and that works in many cases. Not all, but it usually works. So sedges have edges, and this one is unique. This is the lake sedge. And I've got a picture ready to rock here. If you look right by my thumb here, you can see that it's got a structure that's called a periginium that's very unique. So each one of these pieces that make this structure up is called a periginium. That's its female structure, and you can identify every type of sedge species by its unique periginium. So this is the lake sedge, which is very typical to the black ash swamp. Okay, so let me see if I can find some other types of organisms that are unique to this place. A second again. Okay, well, I'm gonna call it quits on actually finding some germinated plants, and I'm gonna cheat a little bit and use my photographs because we're pretty early. It's March 30th, and many things just have not come up yet. So I'm gonna show you via photographs what you might find down here. Here's another tree species, the yellow birch. So the way you'd know it is, well, it's a birch. So somewhat similar to a white birch that we saw on the way down here. But look at the bark. You wouldn't mistake it. It's very different. Kind of a beautiful sheen to it, kind of a coppery yellow, and it's really, really shaggy. So that is the yellow birch. That's a tree species that you might find down here at Black Ash. Now on to forbs, or flowering plants. Love this one. It's not out yet. Marsh marigold. Love this plant. So it's got beautiful sort of heart-shaped rounded leaves and gorgeous yellow 5-petaled flowers. That's the marsh marigold. Just not out yet, but I wish it were. It's fantastic. There's a plant that the flowers look surprisingly carrot-like, and that's the water parsnip. So if you look at this picture right here, and you look at that white seed head, if you know carrots, it's got a very carrot-like seed head to it. The leaves are actually made up of multiple leaflets, and you can see that the leaflets are kind of long and narrow and very slightly serrated. That's the water parsnip. There's another fern that you'd find down here. We're a little further along. And that's the ostrich fern. I mentioned the sensitive fern. Here's the ostrich fern. So it grows a little bigger, maybe 2, 3, 4 feet in length, and you can see how it's got that tapered look to it. So it starts narrow at the bottom, and then it grows wider, 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 and then it tapers off at the end again. So that's the ostrich fern. And then I mentioned this last plant at the floodplain forest, and that's jewelweed, genus Impatiens. So here you go again. This guy is just not out yet on March 30th, but it's got those beautiful orange, kind of French horn looking flowers to it. That's the jewelweed. Now I'm going to show you one more dandy plant that is super cool, and that is something called skunk cabbage. So the skunk cabbage is super cool. I love this thing. It does smell, and so its name is apropos, skunk cabbage. And part of that smell is used as an enticement to bring in flies. And flies are its pollinator. So pretty smart adaptive advantage that it's got, skunk cabbage. Why cabbage? Well, because it's got some pretty big leaves. I doubt they're out yet, but they're coming. Now I'm slowly walking. Oh, I don't even have to walk. Here it is right here. I'm going to show you right here. So this plant right here that's got the kind of purple looking structure, that is skunk cabbage, and it's got this really cool flower in the center. It's called a spadix. Now this is a neat plant. You notice it's one of the few that's actually up here on March 30th, and well, the way it does that is unique itself. This plant can throw its own heat. Yeah, a plant that can throw its own heat, so it can actually use metabolism to throw heat, and it is able to actually melt snow around it. It comes out first in the spring, and of course that's an adaptive advantage because it beats all the other plants in the competition for pollination.